This is question 18 from the third CSAT sample paper. So in this question we're told about a game. There are 3 piles of tokens. I've called them little a, little b and c. In the question they're big A, B and C. I just thought that might be confusing because the players are called Alice and Bob. So I'll use lowercase. These are all strictly greater than 0 and less than or equal to n, where n is some number. Alice and Bob take turns. Alice goes first. And on their turns they can take from some of the piles. They can take x from one pile and y from another. And the only constraint is that x plus y is greater than 0. And the player wins if they take the last token, otherwise they lose. And we're asked, if we try this for every possible value of a, b and c with this constraint, how many games does Alice win? So if you want to have a go at this question yourself, pause the video now. Okay, so first let's think about these. This is a slightly odd description of what it means to take your turn. Let's think about what it actually means. Well, what do we note about this? I have to take some tokens because the total I take has to be positive. But I can take as much as I like, and I can take from either 1 or 2 piles, because either x or y can be 0 as long as the sum isn't 0. So I have to take something. I can take from 1 or 2 piles, like I can choose x is 0 and y is 1. Or I can choose them both 1 or whatever I like, and I can take as many as I like. There's no upper bound. It's also worth noting, since each player must take tokens, that means that the number of tokens which starts off finite has to get smaller, so eventually the last token does get taken. There can't be some kind of draw. Okay, so I think a good way of starting this question is to think about some special cases. In particular, we know that the number of tokens is going to decrease, and eventually someone wins by taking the last token. So eventually the number of tokens gets very small. Or it can do, as we'll see later. Well, we can think about this. So it could be there were 1,000 tokens in each of the first 2, but none in the last one, in which case you can actually win, as we'll see in a second. But we'll start with small numbers. So what are some special cases? Well, suppose there's just 1 token left in one of the piles. Then if I'm going next, I win, right? Because I can take 1 from this pile and 0 from this pile, and then I satisfy the rules, because x plus y is greater than 0. And then I've taken the last token, so I win. Likewise, if it was 1 and 1 and 0, then I can just take 1 from each of these and I win. And these didn't have to be 1, as I just said. In fact, they could be anything, A or A and B. If I have 0 in any of the piles, then I just take whatever's left in the other 2 piles and I win. So the thing you have to notice here is, what happens if there's not 0 in any of the piles? Well, let's think about the minimal case, which is where there's just 1 thing in this pile. What happens then? Well, if there's 1 thing in this pile, and bear in mind the other person is rational and is trying to win, then they want to get to one of these 2 situations, because then they win. And that's actually what happens, because if there's 1 in each of the piles, I have to take either 1 or 2 of them, so I end up in one of these cases. And then the next player clears up all the tiles and they win. So if it's 1, 1 and 1, I lose. And the reason is basically, okay, suppose it's 1, 1 and 1. I take my turn. This is one example. It could be 1 and a 0, or it could be like this. And then you take all the tokens that are left and you win. So now, this is a useful thing to know about games where people are taking turns. If you know cases that will win, you also know cases that will lose. If this is a case where when you take your turn, it puts the other player in a case where they'll win. Okay, so now let's try to build on this and see in exactly what cases Alice can win. Okay, so here's the cases we were just talking about. And now let's try to think about what happens with larger numbers. So let's just start with 2. Well, if I have 2, 1 and 1, now I know if I can get it to be 1, 1 and 1 and it's the other player's turn, then they lose. So if it's 2, 1 and 1, then I just take 1 from the first pile, and then it's 1, 1 and 1 and the next player loses. And likewise, if it's 2, 2 and 1, then I can get it to 1, 1 and 1 and the next player loses. However, what happens if it's 2, 2 and 2? Well, then I have a problem because I have to take tiles. If I reduce any of the piles to 0, I lose because the other player just takes from the other 2 piles. So I only want to take at most 1 from each pile, but if it's 2, 2 and 2, then I take 1 and I end up in one of these 2 cases and the next player wins. So it looks like this. If it's 2, 2 and 2, I want to go to either of these 2 cases and then I lose because that means B is in this position, so they win. So this should suggest a strategy to you. It looks like if all the piles are equal and it's my go, that's bad for me. Because I have to take something that makes them unequal, and then the next player can make them all equal again. And it looks like if you have them all equal, you just keep them equal on the other player's turn until they get to 1, 1, 1 and they lose. So let's try to draw how that might go. So let's imagine I'm going first, and suppose they're not all equal. So it's some number A and then 2 others that are larger, and suppose A isn't 0, otherwise I win straight away, and suppose at least one of these is positive so that I'm not in the case where they're all equal. Well, what's my strategy? I want to make them all equal, and I can do that. I can just take X and Y, and then now if you're playing against me, you're in this case, and you're in trouble because you have to take some tokens. If A is 0, I've already won. Otherwise, we're just going to repeat the pattern. So you have to take something. So you get to some B which is less than A, and then some other 2 things. So one of these might also be equal to B. Like you could take the same amount from these 2, but then this one would have to be larger because you can't take from all 3 piles. And then what do? I just take X dash and Y dash, and then we're back in the case B, B, B. And if B is equal to 0, I win, otherwise we just keep going. So we can see that what happens is, if all the piles are equal, whoever's going now loses. Because either they're all 0 and then the other player just took the last token, so you already lost, or you follow this pattern and they just keep staying equal until the other player takes the last token. And if they're not all equal, then we can see there's a strategy to win. So whoever's going now wins if they're not all equal. So with that in mind, let's count how many games Alice can win. Okay, so just copied in some information. We said if all the piles are equal, whoever's going now loses, otherwise the player going now wins. And we need to count how many games there are and how many of them Alice wins. So we know A, B and C are less than or equal to N. They can take any values in that range. And we know Alice goes first. So if Alice is going first, that means if they're all equal at the start, she loses. Otherwise, they're not all equal and she's the player going now, so she wins. So Alice loses if and only if all the piles are equal. And how many ways are there of making all the piles equal, satisfying this constraint? Well, A, B and C can take any value from 1 to N, so there's N choices if they're all equal. But how many games are there total? Well, we can choose any values between 1 and N for them individually. So it means N choices for A, N for B, N for C, so we get N cubed total games. And that means the number of games Alice wins is just the total number of games minus the number she loses, which is N cubed minus N.